Okay, let me start this lecture number 7. Before we start lecture number 7, we'd like to review what we learned in the last lecture. Okay. Anybody can remember what we learned in the last lecture? Work. Okay. Work or work done? I mean, we use the word work done, right? So more precise language we have to use and remember is work done. Okay, the notation to express work done was, anybody can remember? The notation that expresses the work done. Was it W or U? U. And then subscript? Okay, 1, arrow 2, right? Okay. Arrow has a significant meaning, in fact. What it means by arrow? From 1 to 2, right? What it means by 1? What it means by 1? Okay, state 1. What it means by 2? State 2, okay. That means, if you look at carefully the notation, that possesses all necessary meaning, right? Right? So the notation expresses all the physical meaning in very concise or compact form. So that's very important. Because it expresses the work done from state 1 to state 2, as this notation implies, we can put equal. Okay, equal sign has a tremendous meaning. This is equal to that. Now let's try to express the meaning that it contains in this notation into more physically sensible expression. Okay, work done physically means what? I am doing work here, not this kind of work. The definition of work done is what? Definition of work done. Okay, force times displacement. In vector notation, we could write that is force times the displacement that has been induced by the force during certain period of time. Okay? So I can write that is dr. And I want to summing up all the work done by all the forces. or you may say done by the resultant forces. Okay? So summing up means integration in mathematical term. Right? So bank is kind of integral office because they are getting all of money from ours, right? When bank give you some loan, the bank turns out to be not summing up, but operates as derivative. So integration and derivative has a lot of significant meaning that are pretty much associated with our daily life. It's not just this symbol. It's not just a strange symbol just to stay in the textbook or in a homework or examination. Right? That's very interesting implications that integration and derivative has. Okay. Now I can write this is f dot dr. What it means by dot? Dot. Dot is not simply dot over here. Right? It has mathematical meaning. What it means? The dot, by definition, say, for example, if I have A vector dot B vector, then we remember, not realize, not, really experience, but we remember that can be written A magnitude and a B magnitude and cosine theta. What it means? Okay, to understand what it means, we normally have to transform mathematical expression to graphical expression to understand something. What we usually do is we transform something that we do not clearly understand to another domain. That's why I always emphasize, let's transform, for example, Newton's second law into graphical domain. Okay? So let's do the same thing. So suppose I have A vector, and suppose I have a B vector over here. This is theta, and the magnitude of A vector is simply this, and the magnitude of B vector is simply this. A cosine theta is nothing but I am projecting this vector upon to this vector. Right? So this means projected force. Dot means projected force on r vector or dr vector. What it means physically? Okay, I am applying force to him, and even if I use this vector form, because he is moving this way, the effective force to effectively change the deformation or displacement of this map into direction has to be component which is parallel with his arm, right? So that's physical meaning. So if theta goes to pi over 2 or 90 degree, the work done is 0, right? Okay, that's interesting physical observation. Now, we remember that this force can be related with acceleration, right? That is, resulting force induced motion, resulting force acting on the mass induced motion. And also from kinematic relationship, we can rewrite this is change of velocity with respect to time. And again, we can rewrite this into this form. Wow, this provides us a new measure of dynamics, that is momentum. And the momentum is a vector because that is mv. Of course, this is the case when mass is constant. And this is the case when mass can be assumed to be varied with respect to time. So this is a more general case than this, so we can write this way. We can not write from this expression to that expression unless we assume m equals to constant.